Right. Good morning again. Um, we did the calculation. I remember something like that. Ne? Where we stop?
Calculating equilibrium concentrations.
Equilibrium concentrations, right? Right. We did the calculation, right? That's it.
Yes, sir.
Okay. Right. Then write down Le Chatelier principle. Topic. Le Chatelier's principle. Right. Here, under this segment, we basically talk about when we do some changes or when we change some factors which related to the system, right, or equilibrium, how the equilibrium is response, right, when we change some factors effect on the equilibrium or system, how the system responds for that, right, that's what we talk about here, right. This lecture earlier, he introduced a very important, give a second. Right, he introduced a very important principle. According to him, basically, right, basically he said when we do some changes into system, the response of the system, it try to reduce that factor, it try to reduce that change, right, or this system give some resistance, right. If you reduce something, system try to increase that, right. If you increase something, system try to reduce that, right. Then the equilibrium goes to left in that kind of area, right. So that's the basic idea. Okay, nothing else,
Okay.
right. This theory apply on physical and chemical both equilibrium, right. Okay, just write down, this is literally a principle, the definition. Change in any of the factor, change in any of the factor, change in any of the factor, change in any of the factor any of the factor that determine that determine the equilibrium conditions that determines the equilibrium conditions of a system 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 will cause the system to change will cause the system to change in such a manner system to change in such a manner so continue so as to reduce or counteract the effect of the change counteract the effect of the change clear okay then we're going to talk about one by one different changes okay we're going to different changes right we do different changes and let's see what will happen okay write down the first one effect of concentration change right that's the first change we're going to do right how the system responds when we change the equilibrium right equilibrium change okay write down
Topic or can I write 1, 2, 3 like that?
yeah just write it down as a small topic effect of concentration change effect of concentration change right according to Lecher, what would happen according to him when we change the concentration system act oppositely right system try to reduce that change right if we increase amount of C concentration of C system try to reduce the concentration of C right that means system moves into the reaction the backward reaction is increases right the backward reaction is increases then it produce A and B that doesn't mean it doesn't reduce all the increased amount of the complete the total increased amount into A and B right it doesn't convert like that right but some amount of C reduces and convert into A and B that's the idea right it can't reduce let's say you as I said yesterday I said something let's say you increase by 1 right just go with moles right you if you increase C by 1 mole right the system doesn't reduce whole total 1 mole and doesn't make A and B right it's make A and B up to some level up to what up to the system balancing the ratio means Kc and Kp values, right? Equilibrium constant until it's balanced equilibrium constant, right? That's it. The reaction happen until it's become equilibrium. I mean, the Kp Kc values, right? Until it's reach Kp Kc values, right? When you increase, you have, I mean, it's not equilibrium. Just after increasing, you are at equilibrium, right? You did the change, right? Then you have you can calculate Kc, right? In any situation after change something, you can calculate Qc and you can check whether it goes to left or right. Okay, we can do it. So for now, so just get the idea what happened when we change the concentration. Actually, nothing to remember. What you have to remember, just remember system try to reduce that change, right? System always try to reduce that change, right? System එක මොකද කරන්නේ මේ වා කරපු change එක reduce කරන්න තමයි වැඩ කරන්නේ. හරි? ඒක නැති කරන්න. right. Okay, then write down a point. According to Le Chatelier principle, according to Le Chatelier principle, according to Le Chatelier principle, down by down. First one, the concentration stress of the concentration stress of an added reactant, the concentration stress of an added reactant slash product is relieved by relieved, relieved by net reaction, net reaction in the direction that consumes the added substance, right? Second one, next one, the concentration stress of a removed reactant slash product is relieved by net reaction in the direction that replenishes replenishes, replenishes the removed substance. Is it clear? Right? Just leave a rule and write this stuff. Simply when we change the concentration of reactant or product system try to minimize the effect. 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 Right? That's it. That's the simple idea, right? There's something in science, right? I mean, sometimes they use, I mean, there's a special, I mean, different part called scientific writing also, right? Scientific writing. Scientific writing means writing in Pali or something, right? No one can understand that bullshit, right? Then, yeah, that's true. Scientific writing means no one can understand. When we write something, everyone should understand it, right? Scientific. I mean, I'm not criticizing, but that's a reality, right? In scientific writing, even in Sinhala, මේ සිංහලෙන් ලියුවත් ඒවා සිංහලෙන් ලියලා තියෙනවා ඒක 10 පාරක් විතර කියවට මොකද්ද කියලා තියෙන්නේ කියලා තියෙන්නේ. They use I mean they use some words, even some words they stop using that word I guess 100 years 150 years ago. No, normal people don't use that kind of word. Some words, I mean some grammar, right? We can't understand. They just writing and they just praise about it. Nice writing. Right? That's what I do even when I write something. I mean, in school, I mean, we have to write something called lesson plans, right? So, right? So when I write, then I use kind of I use AI, right? Always I give the prompt, make more advanced terms. Right? When I write in advanced term, no one can understand it. No one knows, even I don't know, right? then someone check the lesson plan, they can't understand. But it's correct because I am using technical terms, right? Technical terms and kind of a advanced grammar. Then it doesn't matter what I wrote. The same thing happened in the university. If someone uses very advanced grammar and then technical terms, I mean that means it doesn't mean you know the subject, right? Even if you know advanced grammar and those things, you can get marks because the lecturers can't understand it. That's why most of the lecturers, they don't know language, right? Yes, they don't know the language. That's right. If you write something, if they can't understand, most of the time you will get the marks, right? Then I mean, first thing you have to understand, to check whether you correct or wrong, you have to understand what you write, right? They have to understand what you write. And when they can't understand, if you have advanced grammar and then looks like she knows something, okay, then most of the, there are some students, Colombo, I mean, those are my friends, right? Most of the time they ask us, right? I mean, we teach them sometimes, right? They ask some subject matters and those things us, right? They call us. Then in the exam, A plus, A minus, we get B, B minus, right? Why? We know the subject, but we don't know how to write. But they don't know the subject; they know how to write in English. That's the trick, right? That's the trick. When we write something, we just explaining in simple words, and we don't know advanced grammar and those simple grammar, right? That's it, right? Most, I mean, for my friends, they from Vishaka and Royal, right? And they know the language. Even knowing about, I mean, even sometimes they know nothing about subject. Even they weren't in this university sometimes, right? We haven't seen them, and then come to the exam and then. But here is the thing. But there is a limitation, right? You can't achieve. I mean, this is not valid for every subject, right? Up to some level, you can survive using English, right? But you can't. I mean, if there's calculation or something, you can't. You can't cheat. Why? You have to calculate, right? There's no grammar, right? You have to calculate. They got lower marks for chemistry. Why? There are some calculation. You have write chemicals, right? No grammar. Grammar doesn't matter when you come to chemistry. But it matters where? In biological subjects, right? Biological subject. You know that, right? In chemistry physics, it doesn't matter. You have to calculate. Nothing to explain. You have to calculate. If you know, right? It doesn't matter, right? Podi they thing you can write. I mean, if you know these very few technical terms, grammar also doesn't matter. They don't care about grammar. If there's a calculation, then done. They got good marks. So botany, zoology, right? Low marks for chemistry, just pass. Chemistry, just pass, right? Right. We have some marks for chemistry, right? We got marks for chemistry, right? Okay. Then, okay, write down example. So here, let's talk about what will happen when we change the hydrogen concentration. What we change here? H2 concentration, right? This is the change, H2 concentration. Changing means H2 concentration increase, right? Okay, what will happen? When you're writing about this part, right? I mean, in the question, don't forget to start from according to Le Chatelier principle, right? Whatever you write is starting from that, right? Like we mentioned before, we use PV equals nRT, assuming these gases are ideal gases, like something, right? Mention Le Chatelier, right? So according to Le Chatelier, what, right? According to Le Chatelier, what will happen here? we increase the amount of hydrogen, right? Then system, right? What system think when we increase the hydrogen? What the hell is going on here, right? So then what system need? System think, okay, I have to reduce this change, I have to reduce amount of hydrogen. Then to reduce hydrogen, what should I do? I should increase the forward reaction, right? I have to increase the forward reaction. When I increase the forward reaction, what will happen to the concentrations of these two factors? When reaction occur into this side, the amount of I, we haven't add I, right? It's the remain I, right? The I at equilibrium. Therefore, amount of I also reduce. Why? The system shift to this side. And what happened to HI? It increase the amount of HI, right? It doesn't reduce the H2, we add it, right? After adding few, a small amount is reduced, but it's already higher than the previous part. Amount of I is reduces than the equilibrium, right? HI will increase than the equilibrium, okay? We can explain it using what? QC also, right? We can explain it using QC. So write down. Do you have any problem? No, right? No? Right. Okay, write down. According to the Le principle, according to the Le principle, according to the Le principle, do I just write it like this? This is the change, and then this is what you're gonna impact, right? How system act, right? මේ දෙකම ලියලා මේක ලියා ගන්න. According to Le principle, system tries to reduce the hydrogen. System try to reduce the hydrogen. System try to reduce the hydrogen. Therefore, forward reaction will increase. Therefore, forward reaction will increase. Forward reaction will increase, or you can say forward reaction will accelerate or anything, right? Get the idea. Forward reaction will increase. Due to that, amount of I2 reduces and amount of HI increases. Okay. Let's make a graph. Okay. Right, look at this graph. Okay, here this is H2, this is I2, this is HI.
Where shall I do it?
Just wait. I just draw the pattern. It's okay. So listen now. What we did, we just increased the here and this in this part. This is the equilibrium, initial equilibrium. We will start from the equilibrium. Right? We start from the equilibrium. Right? We start from the equilibrium and then here we change the system. We did some changes. Right? In the middle. Right? The middle part is in equilibrium. Right? Right? We change, right? We increase the H2. Due to that system, the equilibrium is changed, right? So after that, system become equilibrium, right? You see, the values change, right? It goes to new equilibrium, right? When we change something, it goes to new equilibrium. This is the new equilibrium, right? So here what will happen? Here we can get the idea using case QC, right? Here, what is QC here? Just write the equation for QC. QC HI HI squared over H2 right. Which factor is higher? This one, right? This one higher, right? The concentration of this one increases. That means what will happen? QC becomes lower, right? QC becomes small, right? QC becomes smaller than QC becomes smaller than KC, right? Clear? Right? When this part increasing, the top value reduces, right? Therefore, QC becomes smaller, right? QC becomes smaller means forward reaction should happen, right? Forward reaction should happen until QC equals to KC, right? That's the pathway, right? Anyhow, if we change HI, what will happen? QC gets higher. If QC is higher, QC should reduce us, right? It goes to reducing QC. Then the system goes to backward. That's what happened, right? Just always think with the QC. That's the way, right? Always go with the QC. Okay, then here the system under new equilibrium. This is new equilibrium. Right now system under new equilibrium. මේකත් පෙන්නන්න. Right, write this one also. right. There's another equilibrium given here. බලමු පොඩ්ඩක් equilibrium එක තියෙනවද? වීඩියෝ එක පොඩ්ඩක් බලන්න.
If you got 5 to 8.
Right, this is the equilibrium of iron 3 thiocyanate, right? This is a system, I mean iron and cyanate iron. Okay, it's become red. The iron 3 thiocyanate is a red color, right? Okay. So you can see what will happen. The yellow color means Fe3 plus, right? Yellow color one is Fe3 plus, just Fe3 plus iron na? But Fe3 plus is pale yellow. ලොකු කලර් ගන්න මේකේ මේ FeSCN, right? That's why this is why I always said we can't get the colors using internet, right? Here in the syllabus, FeSCN2 is red color, right? This is orange color, right? So don't consider about the color. In resource book it says Fe3 plus is pale yellow, the FeSCN is red color, right? දැන් ප්‍රැක්ටිකල් එකක් කරලා ළමයා ඕගොල්ලෝ විදියාගෙන ඉන්නවා. හරිද? මම ඒක ඇත්තටම ප්‍රැක්ටිකල්ස් නොකරන තරමට හොඳයි මේ කලර්ස් ගන්න. බයිලා ඒ කියන්නේ මේකේ තියෙන එකක් එන්නේ තව එකක්. But look at the system, no? That's what I want to. What do they add? They adding add reactant, right? They add reactant, right? That means what? They add, I guess, SCNO Fe3 plus, one of them. Then the reaction shift to product side, right? Can I get a higher concentration at them? Yeah, and side area. අනිත් ඒකෙත් reactant ඒ කියන්නේ SCN ඔය දෙකෙන් එකක SCN අනිත් එකේ Fe3 plus, right? Then they gonna add FeSCN, which is product, right? Product එක දාලා බලන්න. ඒක dissolve නෑ remove reactant right reactants remove කරනවා. ඒ කියන්නේ වෙන මෙතන SO3 එකක් දාලා මේ Fe remove කරලා කඩන්න පුළුවන්. What happen when you remove the reactants? Equilibrium shift to shift to backward, right? That means reactant side. මෙහෙමයි මේ අපේ බුක් එකේ කලර්ස් හරි මට පේන්නේ. දැන් මේක බලන්නකො මේක පේල් or yellow මේ පාටක් තියෙනවා. දැන් මේක orange, right? අරක red කියලා කියන්නේ මේ කියන්නේ orange. දැන් මේක orange වගේ නෙමෙයිනේ. පොඩි ලාව orange එකක් තියෙනවා. මේක මේක තමයි red color එක හරි color එක. ඒ කියන්නේ ගොඩක් concentration එක තියෙද්දි red color එක එන්නේ. කලර්ස් ගැන මොරු වෙන්න බෑ අර අයිඩියා එක ගන්න වෙන වැඩේ. remove reactants equilibrium shift to reactants. එතන F එක remove කරා. Fe remove කරා. එතන yellow කියන්නේ colorless මොනවා ගන්න කරනවා. remove reactant equilibrium shift to ඒක මොකද නේද හරි හදන වැඩන අයිඩියා එක ගන්න right that's it අනිවාර්යෙන් right definitely we will get a question about anything right it might be a I mean not only me essay right this thing I mean laterally will comes to MCQs also it will be there right I mean everywhere. So one of the most important part and one of the most important principle. Okay. Okay, then let's write down that equilibrium. Say another example. Just write down consider the following equilibrium. Consider the following equilibrium and then let's write the equilibrium. Fe
Shall I write the equation?
write the equation. Right. Okay, here are the changes, not a one change, right? Changes or effects, whatever, right?
Shall I write that too?
Huh?
Shall I write that too? Changes.
Yeah, let's write the changes. First one. දැන් මෙහෙමයි exam එකේදී මෙහෙම එකක් තියෙනවා. In the exam they don't directly say we, I mean, sometimes they said, but sometimes they don't say increasing Fe concentration, something like that, right? They say something like this. First one, add sodium thiocyanate, CN. Add sodium cyanate. Second one, I mean, okay, let's go one by one. First one, add cyanate, sodium cyanate. What is the change then when we add sodium cyanate? When we add sodium cyanate, it add cyanate ion, right? Then
So is it sodium cyanide or Fe cyanide?
no, sodium cyanate. That's why I said they add, when we want to add cyanate ion, we can't get cyanate ion alone, right? It's not alone, right? It's with someone, right? When we say, we just say, right? In previous one, we just, I mean, hydrogen it's okay, but when we come to ions, we can't add just SCN minus, right? No, SCN minus doesn't exist alone, right? It will with someone, right? It will exist with someone. So this is the one way we add cyanate, I mean SCA, okay? Clear? That's why I said they said something like this. Then you should know what is the change happened by this chemical, right? This chemical will increase the amount of SCA. Clear? This chemical will increase the amount of SCA. Then what will happen when you increase the SCA? Then you know what will happen.
C3 plus reduces.
Right, okay. Okay, then write the answer according to lecture earlier. Okay, explain what happened to the system. Done. Write it in your own words. When you explain, listen, when you explain, first explain what happened due to this chemical. This chemical will increase the SCN ion, right? Start from that. Then, according to lecture earlier, then explain what happened to the system. Okay. And do mention your observation also. What happened to the color, right? When system goes to this side, what happened to the color change also. Mention it at the end.
color observation, it turns to red, right? So I can't hear you.
The solution become red because it form more FeSCN, right? Solution become more red. Then when you add H2C2O4, what will happen? This C2O4 ion can react with Fe, Fe3 plus, right? React means, I mean, it form a complex, right? It forms stable complex. Then what will happen? The concentration of Fe3 plus is reduces, right? Clear? We had this one, what happened? Fe3 plus reduces, right? Then you should understand, knowing what happened isn't enough, right? You should have an idea, but I mean, depend on the compound we add to the system, right? What is the effect of that compound now? According to that effect, what will happen to the system? Clear? You have to idea about the effect of the compound, right? You have to use your inorganic knowledge, right? I mean, sometimes, right? Sometimes they just directly give, right? Anyhow, you have to find when they just give a compound, you have to know what happened. Okay, write the effect of this one. It directly affect on Fe3 plus, right? It reduce the amount of Fe3 plus. Huh? Madhu?
So
For the
the answer for the first one, add NaSCN.
ah, just say what you wrote. You can write it. It's not a
The
hard question. Say it. Say.
NaSCN will increase the amount of SCN minus ion. Then,
Okay. Continue.
according to Le-Chatelier's principle,
System. Yeah.
systems try to reduce SCN minus. Forward reaction will increase. Due to that, amount of Fe3 plus reduces and FeSCN2 plus
Correct.
increases.
Exactly. Exactly. That's the answer, right? Mama Duna Tojjara, right? That's the exact answer, right? Nothing happened beyond that. Okay, then right, what happened to the system when you add H2C2O4? Here, just mention this equation, using an equation. I mean, what happened to Fe? H2, sorry, I mean C2O4 2 minus plus Fe 3 plus, its form a equilibrium. Oh, it's a complex, huh? This oxalate and remove the Fe from the system, right? This is the reality. This is the way we reduce something in a system, right? You can't remove Fe3 plus using your hand, right? We have to add a compound and then you can remove it from the system, right? This is the reaction. So first explain what happened due to H2C2O4. This is the thing happened, and then say amount of Fe decreases, amount of Fe decreases according to Le Chatelier, then explain, right? This one reduces, right? Use the
Should I
same
write the
pattern.
equation?
This is the first one, add in NaCN, and the second one, this one. Second change,
Should I write the equation?
write the equation. Yeah, show it, what happened. First say Fe3 plus make a complex with oxalate, and then mention the equation, and then when you explain something, just using it step by step what happened, right? හැලි ලියන්න නෙමෙයි අර මේක නිකන් පඩි පෙළ වගේ තියෙන ඉස්ටර් එක වගේ අර ගන්න. එහෙම තමයි ඔයා ලියලා තියෙන්නේ හරි. ඒක අර මෙහෙම ඒක මේ ඇඟින් ඉන්නේ අයිඩියා එකක් තියාගන්න. මුලින්ම මේකෙන් මොකක්ද වෙන්නේ ලිව්වා. ඒකින් මේකට මොකක්ද වෙන්නේ ලිව්වා. මේකෙන් සිස්ටම් එකට මොකක්ද වෙන්නේ ලිව්වා. That's it. Then color change එක ලිව්වා observation.
म्यूट करना है
So what's the observation? It turns to colorless.
Observation, the solution become pale yellow or colorless. Colorless colorless පැත්තට තමයි බර වෙන්නේ. මොකද මේක අඩුම වෙලා යනවනේ. මේක අඩු වෙලා මේක නිතුරින් මෙහෙන් හැදුනත් colorless pale yellow දැම්මත් හරි. අර අරකේ දැක්කද එකක් colorlessම වුණා. අර අපේ වීඩියෝ එකේ right. ඒක අර හරියට මේ පෙන්වන්නේ නැහැ මොකක්ද ඇඩ් කරන්න කියලා. මේ ටෙක්නිකලි මේක වෙන්න ඕනේ මොකද මේ Fe නැතුවම ගියාම තමයි කලර්ලස් වෙන්නේ දැන්. එතකොට මෙහෙම හැදෙනවා. හැදුනට අර කලර් එකක් පෙන්වන්න තරම් මදි. එහෙම එකක් තියෙන්නේ. Fe remove වෙන්නේ නැහැ ඔක්කොම. මේ it's not enough to show the color. Right. Then
So what's the
answer, you should include these things. First thing you should say, no need these words, the idea, get the idea. First thing you have to explain what happened to this system when you add H2C2O4 oxalate. You should say it's make a complex with Fe. and write the equation. It's mega complex with Fe. Then you should say it's mega complex with Fe and it reduces the it's reduce the amount of Fe from the system, right? And then write the equation, right? You have to mention those things. Then mention what happened according to Lecher-Elio law, principle. When Fe3 plus reduces, system try to increase the Fe3 plus. Therefore, system backward reaction increases. Due to that, FeSCN
Can't,
decreases. Huh?
can't we write forward reaction decreases?
No, we don't write forward reaction decreases. We just write backward reaction increases. Normal, I can't say it's wrong, but normally we don't write like that. අපි අර අඩු වෙනවා කියලා ලියන්නේ අර increase වෙන එක තමයි ලියන්නේ. Technically හරි. Someone can argue. අර අඩු වෙනවා කියන එකත් හරි. But අරක තමයි method එක. Backward එක increase වෙනවා කියන්නේ. Then FeSCA reduces, SCN increases. Then solution becomes colorless. Clear? The exam එකේ ඔය අහුවම, right? You should cook the paper. You should crush the paper. මේවා තියෙන්නේ. තියෙනවා exam. You don't get an exam without Lecher-Elio and KP-KC, right? It's not a paper without KP and KC and Lecher-Elio. One of the most important part in the exam. Okay, then another example. මේ තියෙන examples ඔක්කොම යම් මොකද මේ පේපර් එකට හැම හත් දැන් මේවා ගන්නවා exam එකේ හරි. මෙහිම දාන වෙලාවල් තියෙනවනේ. ඊට පොඩ්ඩක් මේවා මෙහිම යමු අපි. බලමු අපිට අත මේකේ මේ කොච්චරක් තියෙනවද කියලා QC. ගොඩක් මේ Lecher-Elio part එක සෑහෙන ලොකුයි. ionic equilibrium නේ. ඊට පස්සේ බලමු ionic equilibrium පටන් ගන්න පුළුවන් වෙයි බැරි වෙන එක. නෑනේ. බලමු ෂුවර් නෑ. මේකේ අර තව එකක් තියෙනවා HG දානයක් ඒක ඕන එක හිතා ගන්න. HG දාලා SCN reduce කරන්න දැන් දෙකක් තේරුණාම ඇති يعني එක idea එකක් තේරුණාම ඇතිනේ ඔක කරගන්න පුළුවන්. එකම තමයි pattern එක යන්නේ. ආයෙ ඒක. Okay, consider the following equation. N2 මම ගොඩක් calculation එකක් එක්කම තියෙන එකක්. Okay. Write this equilibrium and write the following data. Assume in this equilibrium mixture assume in this equilibrium mixture assume in this equilibrium mixture 0.5 mol dm minus 3 into 0.5 mol dm minus 3 into comma 3 mol dm minus 3 H2 and
0.5
1
N2 and 3 H2.
3 H2, right? 3 mol dm minus 3 H2 and
0.5 will be N2, right?
0.5 N2 1.98 mol dm minus 3 NH3. Continue. What will happen if we change the concentration of N2? What will happen if we change the concentration of N2 to 1.5 mol dm minus 3? Right. First thing, right? This is not exact question, right? These are examples. I just gave it as a question, right? So first explain qualitatively. What is qualitatively? How to explain qualitatively? Just say what happened, right? Qualitative. No any calculations, right? Then later let's find it. Let's explain it quantitatively. First explain qualitatively and then let's explain it quantitatively, right? So first explain it qualitatively. You can do it, right? Explain the system qualitatively. What happened to the system? Continue කරන්න යන්න. qualitative හොයන්නත් පුළුවන්. ඔයාට මෙහෙමයි මේකේ graph එක ගහන්නත් පුළුවන්. right? මේ type එකේ graph එකක් තියෙනවා. ඔය type එකේ graph එකක් තියෙනවා. graph එක ගහන්න ඕනේ මම එකක් කියලා දෙන්න. මේ explain කරන්නකෝ බලන්න. continue කරන්න මම එන්න චුට්ටක්. Right, what happened?
Yes.
You have to say according to Lechertier principle.
Same concentration of
Concent- concentration of N2
N2
should reduce.
increases.
Therefore,
The system
read
try to reduce N2, so forward
it.
reaction will increase. Due to that, amount of H2 reduces and NH3 increases.
Right. Okay, then let's make a graph.
So in the exam, will they ask like explain qualitatively, quantitatively, or
Sometimes
shall
they said
we
මර
write
හැමතිස්සම
it
නෑ
as
ඔව් හැමතිස්සම කියන්නේ ඒක අර කොමන් ටයිප් යන්නේ මේ මම අර මෙතෙන් දෙවේ එහෙම අහපු වෙලාවල් තියෙනවා කියන්නේ ක්වොලිටේටිව් දැන් නිකම්ම එක්ස්ප්ලেইন කරන්න ගියාම සමහරවිට ක්වොලිටේටිව් කියලා කියන වෙලාවල් තියෙනවා නිකම්ම එක්ස්ප්ලেইন කරන්න කියලාත් කියනවා දැන් අර yesterday question එකේ මතකද ඊයේ කරපු එකේ නිකම්ම අපිට මේ එකක නිකම්ම හොයන්න තිබ්බ අනිත් එකේ QC දාලා හොයන්න තිබ්බනේ දෙකක් තිබ්බනේ දෙවිදිහකට right ඒකට අර ඒක ටර්ම් එක කියන්නේ අර කිව්වහම තැනේ හැටියට බලන්න ඕනේ just explanation then just say what happened right it's enough according to lecture this thing happened දැන් ඔය මම ඔය කියන ඔක්කොටම එක්සෑම් එකේ මාක්ස් දෙන්න හැබැයි ඔක තමයි කම්ප්ලීට් ආන්සර් එක right සමහරලාට ෆුල් එකටම දෙනවා සමහරලාට මේ දෙනවා හින්දා ලියද්දි ෆුල් එක හරියටම එක්ස්ප්ලනේෂන් එක ලියනවා හරි නිකන් just මොකද්ද වෙන්නේ කියලා සමහරලාට අහනවා දැන් රියැක්ෂන් what happened to the reaction of the reaction හරි මොකද එහෙම අහන්නේ මොක ඇහුවත් ඔය සෙට් එකම ලියලා දාන්න. එතකොට ආයේ මොක දුන්නත් දෙනවා මහ වෙනසක් වෙන්න වෙලාවක් යන වැඩක් නෙමෙයිනේ. right. ඉතින් අපි හිතන්නේ තැන් වලට සමහර sometimes they allocate marks even I don't think right. එහෙම marks allocate කරන වෙලාවල් තියෙනවා. ඒ තැනේ හැටියට marks ටිකක් තියෙනවා ඉතුරු වෙලා දෙන්න දරකුත් නැහැ දෙනවා. හරිද? මන් දන්නේ එහෙම දෙන්නේ කියලා. right anyhow here the initial amount is 0.5 right that's the lowest one this one නේ මෙතන 13 නෙමෙයි 3 then 3 is the highest one then 1.9 is second highest the order change here we increase the amount of N2 NH3 will increases H2 එක තව චුට්ටක් උඩට කරලා නැත්නම් පැටලෙනවා this side is concentration na you know that ne this is the make it QC එක QT right QC is smaller than KC right therefore මේට නගලා එමත් කිව්වේ. මේක එක්සාම්පල්ස් ගොඩක් කතා කර කර යද්දි චුට්ට වෙලා යනවා. මේක තියෙනවා. This is the third day, I think. Equilibrium third day. අද තුන්වෙනි දවසේ මම හිතන්නේ equilibrium වල මේ තා දෙක අවුලක් නැහැ. දවස් තුන අපි equilibrium වලට මේ ලේචර් ලිය කම්ප්ලීට් කරා කියන්නේ සෑහෙන එකක්. මේ අර පටන් ගත්තත් නැතත්. Right. Then right. මේ ගන්න ඊට පස්සේ අපි ලියමු ආයේ මෙහෙම ලියමුකෝ. explain the direction of the reaction using QC. Explain the direction of the equation using QC. Right, Kc is 0.29. It's already given. Right, Kc is given. So find QC. Find QC and compare the values. Right, compare the real values and then explain due to that reaction goes to that side. Okay. Finish. What is Kc? Right? Just apply the numbers.
2.273.
Huh? Point.
2.3.
Right. Let's see. 1.98 squared. When we use QC, we just put the values, the remain values. Huh? We don't care about the equilibrium. These numbers will change after equilibrium. I mean, when it comes to equilibrium, right? This is before the equilibrium, just after change, right? Initial just change 1.5, but still we have 3 moles of H2, 1.98 moles of NH3. H2 3 squared. Three square means 9.
3 cube, right?
Yeah, 3. Sorry, 3 cube. Right. Finally came. I thought I have rescheduled the class at night. You wanna read the back to the down, I think. May.
Okay, I can't see you.
Yeah, you can't see. Sorry. Right. May. මම රෙද්ද. දැන් ඉස්සරහට ඕක වෙයිද දන්නේ නැහැ දිගට මේ දැන් මම බය ඉන්නේ අර මුන් මේ කොහොමද දැන් යුද්ධෙත් යනවා. මේ අර ගල් අඟුරු කේස් එකකුත් තියෙනවානේ ගල් අඟුරු වලත් අර මේ දන්නවනේ අර ගල් අඟුරු ඇහුණාද ගල් අඟුරු කේස් එකක් තියෙන එක දන්නවද ඇහුණාද ඒක දැක්කද ගල් අඟුරු ඈ මොකද්ද කියලා තේරුණාද ඒක ඒකේ මෙහෙමයි කියන්නේ දැන් there are different levels of coal, right? Levels means quality, different qualities, right? Quality means we measure the quality based on the energy, released energy when we burn it, right? Amount of energy we can get by burning, let's say 1 kilogram, right? The problem is the coal now they have the stock they brought has very low energy, right? I mean, let's say earlier when you burn 1 kilogram you will get 1000 joules. Now it's less than 1000. I mean, not little bit but very less than 1000, right? That's the thing, right? ඒතකොට ඒක අර සෙල්ලමක් නෙමෙයි. මොකද දැන් කලින් ටොන් එකක් තිබ්බනම් ටොන් එකකින් ගත්ත එනර්ජි එකෙන් කොච්චරද? ඒකෙන් සෑහෙන අඩු ප්‍රමාණයක් දැන් එනර්ජි එක ගන්න පුළුවන්. බර්න් කරලා. හරි? නිකන් හිතන්නකො ගෙදර දැන් ඔය දරවලක් තියෙන දැන් හොඳ දර තියෙනවා නරක නිකන් නේ ෆයර්වුඩ් වල හිතන්නකො ඒකේ තියෙනවනේ කියන්නේ සමහර දර පිච්චුවම හොඳ මුගක් වෙලා බර්න් කරන්න පුළුවන්. හරි? සමහර ඒවා නිකන් වෙයෝ කාලා හරි මොකක් හරි වෙලා තිබ්බොත් එහෙම මොකුත් නැහැනේ. අන්න ඒ වගේ එකක් ඒතකොට මෙහෙම කරද්දි දාලා ඉවරයි ඒවා. ඒකට එහෙම ඉෂුව එකක් තියෙන ඒකත් එක්ක ඩීසල් බර්න් කරනවා කියලා කියන්නේ මික්ස් කරලා. මේ එතකොට මේ ඒක තමයි ඉෂුව වෙලා තියෙන්නේ. එතනත් ඒ කියන්නේ එතකොට එහෙන් ඩීසල් යනවා. ඒ කියන්නේ අපිට තියෙන ස්ටොක් එකක් තියෙනවානේ. එතකොට සෑහෙන amount එකක් ඩීසල් යනවා එහෙන්. ඒතර ඕකයි මේක ඔක්කොම ටික මේ අර දැන් මේකත් අර කරුමෙට මුන් ගෙනාවු ස්ටොක් එක අවුල් වෙලාවෙම තමයි යුද්ධෙත් පටන් ගත්තේ. නැත්තම් උන්ට ෂේප්පක් දාගන්න තිබ්බා. මේ නැත්තම් කට්ටි ෂේප් එකක් දාගන්න මොකක් හරි කරලා. දැන් උන්ට ෂේප් එක දාගන්න බෑ වැඩි නෝන්ඩි වෙලා තියෙන්නේ. දැන් කොහොම හරි අපිට මේ එක දෙයක් එක හොඳක් සිද්ධ වුණා. මේ මයිදත් කිව්වද නේ කියන්නේ. දැන් අපි අනුරට ඡන්දේ දීලා මේ වෙච්ච එකම එක හොඳක් තියෙනවා. මේ ඒක තමයි මට තේරෙන හොඳේ. දැන් අපි බැරි වෙලාවත් අනුරල වගේ කට්ටියක්ව ගෙනාවේ නැත්නම් එහෙම බැරි වෙලාවත් සජිත් හරි රනිල් හරි ආවනම් එහෙම මේ අපි හිතනවා අනුරාව නම් මාර හොඳට කරයි කියලා. අනුරාව නම් මාර හොඳට කරයි කියලා අපි හොප්ස් තියාගෙන ඒකද දැන් ගියාම අරුව නෑ කට්ටියට. දැන් අර අපි ඡන්ද දුන්නානේ දැන් ඒ හොදමුන්ටත් හොද ගන්නත් බෑ දැන් මුන් ගහලා තියෙන ගහිලි ටික. චාටර් වෙලා තියෙන චාටර් විල්ල මේ මොක හරි දැන් අරුන් හදපු QR එක මුන්ට හරියට දී ගන්න බෑනේ. අවුරුදු 76ක් තිස්සේනේ. අවුරුදු 76ක් තිස්සේ රට කාලා ඒ හදලා දීපු QR එක මුන්ට හරියට දී ගන්න බෑ. දැන් උන් අර මාර මැජික් එකක් පෙන්වන්න නෑ වෙයි ලබ්බ තමයි අවුරුදු 76ක් තිස්සේ කාලා තියෙන්නේ. මොකද්ද මේ හරි ඇති උන්ට බයින්න මම මේ කරන් ගියේ හින්දා මම බැන්නේ බෑයකෝ. මොන රෙද්දක්ද? ඉස්සරහට කපන්න ගනිත් දන්නේ නැහැ පව කට්. මම දන්නේ නැහැ මොකක් හරි නොත් එහෙම දැන් එහෙමද ඔයත් එක්ක නම් අවුලක් නැහැ. අපි මොකක් හරි මැනේජ් කරගෙන ටයිම් එක මොකක් හරි මැනේජ් කරගෙන try කරමු. මේ කියන්න බෑ දැන් ළමයි 3-4 දෙනෙක් ඉද්දි ඉතින් බෑනේ මොන රෙකෝඩින්ග්ස් දාන්නද මොනවා ගන්නද කියලා හිතා ගන්න බෑ. රැයට පව කට් යන්න ගත්තොත් ජෙනරේටර් එකක් ගෙනාවත් ඉතින් ඒකට ගහන්නත් තෙල් නැහැනේ. තාම මේ බයික් එකට තෙල් ගහන්න කියන්නේ අර ගෙදර ගෙනල්ලා අර කලින් ඒ බයික් එකේ ඉතුරු තෙල් ටික තමයි තාම යන්නේ. පෝලිං වල ඉන්න ඉතින් වෙලාවක් නැහැ නේ. පැයක් කමාර පෝලිං වල ඉන්නේ කොහොමද? මිනිස්සු කොහොම ඉන්නවද මන්ද? පැය ගණන් වාහන දාලා ගිහින්. හරි. ඇති ඉනෆ් ඒක ඇති. මේක අපි කර කර හිටියේනේ. මේක හොයලමු උඩ. ආන්සර්කාරීට. මේකේ එන්න ඕනේ 0.0968. පොඩ්ඩක් බලමු මේක එනවාද කියලා. මේක ආවනම් හරි. Right. Right. So this one is smaller than Kc, right? Smaller than Kc. Kc is this one, 2.9, right? Kc is 0.0968 and this one 0.29. Right, until it reach Kc, the reaction will happen. It's enough. Then write down the next small topic. Leisurely principle to solid gas systems. මේ ටොපික් එකක්ම නෙමෙයි මේකෙත් අපි එහෙම දාගන්න එපා. ටොපික් එක ගන්න මේ නිකන් ලියන්නකෝ. apply leisurely principle to solid gas systems කියලා මේක අරකෙම පාර්ට් එකක් concentrations වලම පාර්ට් එකක් තමයි මේක. මේක එක්සැම්පල් එකට යන්න.
Apply exactly as principle to
Just say it again. Principle, laterally principle to solid gas system. Solid gas system.
write the equation.
Yeah, write the equation. Come on, equation. Yes, it's better to say consider the following reaction or something. It's okay, just write the equation. Anyhow. Right. Right here, these are the changes we will do.
Fe aqueous, right? 2Fe.
No, Fe liquid. This is a reaction happen in blast furnace, right? One of the reaction. It's liquid. Right. These are the changes. Right. Can you see how much important this concept when we come to industries, right? Here, this is a reaction happen in blast furnace, right? So, we in industry, what we need, we have to increase the yield, right? We have to increase the yield, right? So, we can use this Le concepts to increase the yield. මොකක් හරි සද්දයක් ඇහෙනවද? නෑ නේද? අහලා නෑ right. නැත්නම් කවන්න නෑ හුණොත් පොඩ්ඩක් කියන්න. Right, so we can use this concept to increase our yield, right? What is the yield here? Fe, right? We have to produce Fe, right? That's what we do. So we can use this concept to increase the yield, right? So what are the things we can do to increase the yield, right? You will learn it in last lesson, but the same concept, right? Later apply in every industry, right? So according to the later we can increase the yield, right? So okay, here just talk about these things, right? We don't need to talk about how to increase the yield. We will see what happen. So what will happen when we add Fe2O3 hematite? What will happen? Can you explain what happened? Huh? Okay, then write it. First one. Oh, we don't write this one. What happened? This is a solid. Do you remember yesterday? Does it affect? Right?
No.
It doesn't even affect on the KPKC, right? Equilibrium constant. It doesn't matter. Solid doesn't matter, right? amount of solid, right? Whatever we do, solid doesn't affect on the equilibrium. We need some amount, that's it. If it's present, we don't need to care about solid. Okay? ඒක අපිට අදාළත්වයක් නැහැ. And then
So it
adding
doesn't
Fe2O3.
doesn't affect.
Yeah. So write for the adding Fe2O3. Write down. Fe2O3 is a solid, therefore Fe2O3 is solid, therefore okay, just write this and then I'll explain. Therefore, concentration of Fe2O3 does not change. Concentration of Fe2O3 does not change. Concentration of Fe2O3 does not change. Concentration of Fe2O3 does not change by adding more Fe2O3. Therefore, it doesn't affect on the equilibrium. Therefore, it doesn't affect on the equilibrium. Right? Why the concentration of solid doesn't change when we increase the amount? Why its concentration doesn't change? Solids වල concentration එක change වෙන්නේ නැත්තේ ඇයි? ළමයි ඒක solid එකන්නේ. It has its own volume, right? Can you understand it? Like solid එකක් ගත්තාම it's not like a liquid. When you add the solid, right here there are some solid, you add more solid. What will happen? It doesn't change concentration because of the volume and amount, right? මේක තියෙන එකම ඒ කියන්නේ මෙතන මේ සෙට් එකේ තිබ්බ වොලියුම් එකයි මෝල්ස් ගානයි ඒකම තමයි අලුතෙන් දාන එකෙත් ඒකම තමයි අරන් එන්නේ. It doesn't mix නේ. mix කරා කියලා තාපහුව එන්නේ දැන් මේක මෙහි බ්ලොක් එකක් නෙමෙයි powdered කරලා තිබ්බත් its own volume is doesn't change, right? It doesn't change. ඒක idea එකක් ගන්න හොඳට. ඒ කියන්නේ that's why we can remove solid from the equilibrium, right? We can't change it. It has own volume. I mean, when we add liquid into, any liquid something into a solution, it will spread everywhere throughout the solution. But solid, it doesn't spread, right? That's the idea. It doesn't spread. Even when we make powder, it's in a powder, right? If you consider the amount of powdered particle, it has a specific volume, right? But solid and gases, it's spreading, right? Clear? ඒකයි එතන කතාව, right? But simply just remember it doesn't affect, right? Right. Then next one, removing CO2. Then you can write the answer. This one easily. What will happen if you remove CO2? This one liquid, right? It will affect, right? When you reduce CO2 amount, it will increase the forward reaction and it goes to increase the amount of Fe. You can increase the yield, right? අඩු කරද්දි මෙහෙට දෙනවා. හුඟක් වෙලාවට අපි When we do industries, we remove the products, right? When we remove the products, the system increase the production of that products, okay, forming of products, okay. Right, what happened when we remove CO2?
What should I write?
Huh?
What should I write?
Yeah, just right. Hurry up. ඕක මාර දෙයක් නෙමෙයි, අර අච්චර මේ කැල්කියුලේෂන්ස් කරාට පස්සේ. මේ එක්සාම්පල්ස් ඔක්කොම කරන්න බෑ. රිසෝස් බුක් එක රිෆර් කරන්න වෙනවා දරුවෝ. මේ කන්සෙප්ට් එක එකයි, ඔය ඔක්කොගෙම කන්සෙප්ට් එක එකයි. ඩිෆරන්ස් එකක් නෑ මොකුත්. Right. Removing CO2 and removing CO දෙකම ලියන්න.
What happens if we remove CO?
Huh?
What happens if we remove CO?
When we remove CO, the reactants reduces. Then the system try to reduce that change, right? Avoid that change. Then system increase the backward reaction, right? It will increase the backward reaction, and these products will reduces, right? Product will reduces. Right. මේක අඩු කරමින්ද ඒක වැඩි කරන සයිඩ් එක රියැක්ෂන් එක වෙනවා. Right. Then enough. enough. Then write down is small topic. Changes in pressure and volume. Changes in pressure and volume. Next change. Here we talk about change of concentration. Next change in pressure and volume. Right. So the principle is, Lechardy principle is valid for whatever the change, right? System try to reduce that change, right? If we change the pressure, example, let's say, into plus finished. Here, if you reduce the pressure, let's say you increase the pressure. If you increase the pressure, the system try to reduce that change, right? Whatever you do, system try to reduce that or avoid that, right? If you reduce the pressure, what will happen? If you reduce, system try to increase that. System try to increase the pressure. How it can increase the pressure? System එකට pressure එක increase කරගන්න පුළුවන් විදිහක් තියෙනවද මෙතන? Right? These are gases, right? This side, how many gas molecules? Here there are 4 gas molecules, right? This side only 2 gas molecules, right? You know gases, I mean, when you come to gases, the molecule or whatever gases are gases, right? Doesn't matter whether it's ammonia or what. If it's a gas, it's a gas. Here, it's formed 2 molecules. In this side, it has 4 molecules. What will happen if it's form? I mean, if the reaction goes to left side or backward reaction happen more. If initially if there are 2 moles of gases, I mean, maybe with them 2 gas, 2 moles තියෙනවා. දැන් මේ 2 moles වලින් මේකට ගියොත් එහෙම completely උනා හරි කියලා හිතන්නකෝ. Pressure එක මොකක්ද වෙන්න ඕනේ? Pressure is directly depend on the number of moles, right? That means what will happen if we reduce the pressure? The system can increase the pressure by shifting the side that has more gas particles, right? කියන්නේ gas particles වැඩි side එකට shift වෙලා pressure එක increase කරගන්න පුළුවන්. එයාට increase කරගන්න කියන්නේ he tries. ඒ system එක try කරනවා. හරි? ඉතින් increase වෙනවා කියලා ගන්න system එක try කරනවා අර side එකට යන්න. එතකොට laterally, according to laterally, the system should move to here. Here the system should move to left side, right? Whatever, I mean, according to the pressure, it's move. I mean, the weight increase the pressure by moving the side that has more gas particles. The weight reduce the pressure by moving the side that has lower gas particles. Clear? If the number of gas particles are equal, system can do nothing. System එකට මොකුත් කරගන්න දෙයක් නැහැ. ඉතින් චේන්ජ් කරා කියලා මොකුත් වෙන්නේ නැහැ නේ. තේරෙනවද? very effect එකක් වෙන්නේ නැහැ. එහෙම ගත්තොත්. Okay. ඒක ලියා ගන්නකෝ. according to Lechatlia අපි වෙන වැඩි ලියලා ඉමු. according to Lechatlia an increase in pressure an increase in pressure by reducing the volume by reducing the volume will bring about net reaction in the direction that decrease the number of bring about net reaction in the direction that decrease the number of moles of gases. Gas. Next one. A decrease in pressure by expanding the volume. Decrease in pressure by expanding the expanding the volume will bring about net reaction in the direction will bring about net reaction in the direction that increases the that increases the that increases the that increases the number of moles of gases that increases the number of moles of gases. That increases the number of moles of gases. Right. මේකට ලියමු change decrease the pressure. Example කියලා දාගන්න මේක example. Decrease the pressure. මෙතන අපි specify කරලා කියන්නේ by volume මොකද if we change the pressure by temperature it's different, right? Temperature වලින් change කරොත් එහෙනම් වැඩේ වෙනස් වෙනවා. මෙතන specify කරලාම කියන්නේ ඒකයි. Right. What happened? According to the Le Chatelet principle, system tries to increase the pressure. System try to increase the pressure. Increase the pressure. Left side has more gas molecules. Therefore, system increase the backward reaction. System increase the backward reaction. Due to that, NH3 decreases, N2 and CH2 will increase.
So can you repeat again?
මේ ඒක මොන් නෑ මේ ලිවන හරි කිව්ව ටික කොහොමද ලිව්වේ ඕකේ write down මට මතක නැහැ ඔක්කොම එහෙම කියන්නේ කවන්න get the idea, right? Get the idea. You said the idea. You have to mention according to Le Chatelier, system try to increase the pressure. You have to mention that system try to increase the pressure. Left side has more gas particles. Therefore system moves to backward. And backward reaction increases. Therefore backward reaction increases. Never say explain what happened to the amounts. NH3 reduces, H2 and N2 increases. ඔය ටික තියෙනවා නම් හරිය. නෝට් එක ගෙන්න ගන්න ඕනේ. නෝට් එක ගෙන්න පොඩ්ඩක් කියලා බලන්න ඕනේ. අර ඉනෝගැනික් එකේ වගේ. තිබ්බොත් එහෙම තමයි අමාරු ඉනෝගැනික් එකේ වගේ. මේ ඒකේ පොඩ්ඩක් ඉනෝගැනික් එකේ බලන්න ඔයාගේ මේ මට මේ දැන් මතකුනේ 6 group එකේ 16th group එකේ මේ H2O2 වෙන තැනකට H2O දාලා ලියලා. මේක දැක්කහම පේන අවුලක් කියලා. මේ ලොකු දෙයක් නෙමෙයි ඈ. මම මතක් වෙලා කිව්වේ. මේ මම කිව්වෙත් නැත්te ඒක මට දැන් ආයෙ මතක් වුණේ. මේ H2O2 වෙන එකක්. ඒ කියන්නේ H2O වලින් පටන් අරගෙන මොකක් හරි ලියලා තිබ්බා. ඒක පොඩ්ඩක් හදාගන්න. චූටි එකක ඒක දැක්කහම පේනවා. ඒ කියන්නේ දෙපැත්තෙම H2O තියෙනවා. ඒතකොට පේනවනේ. වෙන්න බෑ කියලා. Reaction එකේ දෙපැත්තෙම both side have H2O. Right? It can't be. One side should be H2O2. Right? ඒවා ඉතින් අපිටත් වෙනවා. ඒ මහ දේවල් නෙමෙයි මම මතක් වෙලා කිව්වේ. මේ right. clear නේ? Then එතකොට දැන් මෙහෙමයිද gas particles නැත්තම් pressure doesn't matter, right? Pressure doesn't affect on the equilibrium. If there's no gas particles or the gas particles are equal in both sides, right? Clear?
Yes, sir.
Just write down if the equilibrium doesn't have gas molecules, if the equilibrium doesn't have gas molecules, or if the equilibrium doesn't have gas molecules, or if the equilibrium doesn't have gas molecules, or the number of gas molecules are equal in both sides. The number of gas particles or molecules are equal in both sides. Pressure doesn't affect on the equilibrium. Pressure doesn't affect on the equilibrium. Right? Clear, ne? Just underline or do something. It's important. Then next one, effect of inert gas addition. Effect of inert gas addition. Effect of inert gas addition. Yeah, next one. Next effect of inert gas addition. Inert gas addition. What is inert gas? The gas that doesn't react with other compounds, okay, other molecules. So when we add inert gas, nothing happened, right? It doesn't change the volume, it doesn't change the pressure, right? Pressure means for the equilibrium, partial pressures are effect, right? Partial pressures will increase. Only partial pressures are effect. Therefore, by adding inert gas, and is there any reactions with that gas, right? So it doesn't affect, right? Nothing happened to the equilibrium by adding inert gas. Okay, inert gas එකක් දැම්මම මුකුත් වෙන්නේ ඇයි? It changed nothing, right? It's changed nothing, right? Partial pressure doesn't change, concentrations doesn't change, and the volume doesn't change. Total pressure will change, but total, we don't talk about the total pressure, we need partial pressures, right? අපි partial pressure එක තමයි consider කරන්නේ. Okay, write down. By adding inert gas, equilibrium cannot change. By adding inert gas, equilibrium cannot change. By adding inert gas, equilibrium cannot change. Right. ඇතිනේ වෙන දේ කියලා යන්න දෙයක් නැහැ ඉතින්. මොන්න. ඒක මේවා කරලා තියාගන්න. ඒ කියන්නේ ගෑස් එකක් කැට් කරාම ඉක්විලිබ්‍රියම් එක චේන්ජ් වෙන්නේ මේ ඒක මොකක් හරි රියැක්ෂන් එකකට ඉන්වෝල්ව් වෙනවා නම් තමයි. If it doesn't involve, reaction, nothing happen, right? But if it's involved, we don't say it as a inert gas, right? Inert gas එකක් කියන්නේ රියැක්ෂන් එකකට ඉන්වෝල්ව් වෙනවා නම් ඉන්වෝල්ව් වෙන්නේ නැත්නම් ඉෂුව එකක් නැහැ. හරි? ඒකත් ලියමුද? When we add a gas, when we add a gas, it will change the equilibrium. 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 It will change the equilibrium if it participate for the reaction. If it participate for the reaction. If it participate for the reaction. Right. That's it. Huh? Inert gas එකක් participate වෙන්නේ නැහැනේ. Okay, then next one of the important change, effect of temperature change. Effect of temperature change. Effect of temperature change. Right. What will happen when we basically don't think about the equilibrium, think about kinetics. What will happen when we increase the temperature? When we increase the temperature of a reaction. මේ temperature කතාව සමහර අය අර වැරදි දැනකින් අල්ල ගන්න එකයි. මොකද වෙන්නේ when we increase the temperature? According to kinetics, there is a very common idea when you increase the temperature. What happened? What happened to the reaction? Huh?
Something will
Say it, say. Cool. Unmute කරලා කියනවා ඉතින්. කියනවා දන්නේ කියනවා. බයින්න ඒක. Say something.
will happen.
It will happen.
Something will happen.
something will happen. Everyone knows something will happen, even if you ask it from the ask it in grade 11 one, then they also know something will happen. Not something will happen, they know the thing happened in O levels one. What happened when you increase the temperature? What happened to the speed of the particles? It will increase. Then the collisions increases, right? Then what happened? The rates increases, right? It's valid for every reaction, right? Whatever the reaction, whatever the reaction, even for biochemical reactions up to some temperature, up to some limit, it's valid. It's legit. When you increase the temperature, it will increase the rate. Okay, just keep it in your mind. Huh? Okay, when we come to equilibrium, what will happen? In equilibrium, there are two reactions, forward reaction and backward reaction. According to kinetics, what will happen? Think in kinetic perspective. It will increase the speed, then speed of the particles, and then increase the rates, right? Increase the rates. What will happen? The reaction rate, when reaction rate increases, when reaction rate increases, the thing happen, system goes to equilibrium very quickly, right? System goes to equilibrium very quickly. That means the first idea, the speed of both sides, for both reactions, forward and backward, both will increase, right? But it's not over. It will increase. Remember that, huh? Because sometimes students think, okay, just keep it in your mind. Huh? Both reaction speeds will increase. It's legit according to the kinetic theory. Kinetic theory that you learn, right? Rates increases. Then I'll come to equilibrium. According to the Lechatelier, what Lechatelier said, when we increase the temperature of the system, system should try to reduce it, right? How the hell this system reduce the temperature? How does it reduce the temperature? It should reduce, according to Lechatelier, it should reduce, right? Kinetic එකත් පැත්තකින් තියාගන්න. Then goes to Lechatelier. The system should reduce the temperature. Temperature means heat, right? We increase the heat, right? Then what's related with the heat? These reactions, exothermic and maybe endothermic. Then if we use the heat, what will happen? Increasing the temperature means apply heat, add heat. If we add heat, if we give heat over temperature, right? If we increase the heat, system should try to reduce the heat. How to reduce the heat? The system have to absorb the heat, right? System have to absorb the heat. How to absorb the heat? Which by doing endothermic reaction, right? So then what happens? Then I said it increase the endothermic reaction, right? If we increase the heat, right? Before that, I said the speed of both reactions increases, right? පටල ගන්න එපා. The idea, both reactions, the reaction of both reactions increases, but equilibrium goes to the side of endothermic reaction, right? Endothermic side එකට වැඩිපුර වෙනවා, right? පටල ගන්න එපා. දැන් සමහරව හිතන් ඉන්නවා මේ when you increase the heat, endothermic reaction will increase and exothermic reaction will reduces, right? endothermic එකේ rate එක වැඩි වෙනවා, අරගේ rate එක එහෙම ගන්න නෙවෙයි. දෙකේම rates වැඩි වෙනවා. goes quickly, right? achieve equilibrium very quickly, right? achieve equilibrium very quickly. Reaction of both sides will increase. The endothermic one increase more, right? ඒක ගොඩක් වෙනවා, right? තේරෙනවද? ස්පීඩ්ස් වැඩි වෙනවා අරක වැඩිපුර වෙනවා. හරි පටල ගන්න එපා. මොකද MCQs වල දුන්නාම මේ ටෙම්පරේචර් එක වැඩි වෙද්දී අර එකක් විතරක් නෑ. කයිනෙටික්ස් කියලා එකකුත් තියෙනවනේ මතකනේ. කයිනෙටික්ස් වල කියන්නේ අර රියැක්ෂන් එක මෙහෙම යනවා. Overall, I mean, when you increase the temperature by 10 Celsius, 10 units, reaction speed double, right? Remember? මතකයි නේද? reaction speed එක double වෙනවා 10 වලදී. 10 වලින් increase කරාම average. ඒතර එහෙම එකක් තියෙනවා. ඒතර දෙපැත්තටම වැඩි වෙනවා. හරි? අපි තව ටික අර ඉන්ඩස්ට්‍රීස් වලදී එහෙම හුඟක් ඕක යූස් වෙනවා. ඒතර මතක තියාගන්න. So if you reduce the heat, what will happen? The reaction tries to increase the heat, right? Increase the heat, right? Heat means, I mean, temperature. If you reduce the temperature, reaction will release more heat. So then it goes to the side that increase the heat, right? Faster. Faster නෙමෙයි දැන් temperature reduce කරාම මොකද වෙන්නේ? දෙකම slow down එකක් එනවා. හැබැයි අරක වැඩිපුර වෙනවා. පටල ගන්න එපා ඈ. ඔක හුඟක් පටල ගන්න දරා. කන්සෙප්ට් එක තියාගන්න. කයිනෙටික් කියලා ඉගෙන ගත්තා නේ ඒකත් තියාගන්න. ඔක්කොම ලින්ක් කරනවා. දෙකේ පැටලෙන එකක් නැහැ. හරි? පැටලෙන එකක් නැහැ. ඉක්විලිබ්‍රියම් එකට එනවා ටක් ගාලා. හරි? ඒකයි කතාව එතන. Okay. Write down the equilibrium constant for the exothermic reaction මේකේ තව එකක් මට අර ඉම්පෝර්ටන්ට් තව පාර්ට් එකක් කියන්න දැන් මේකෙදි in temperature we explain it from the beginning. Kc and Kp depend on what? We said those are constant depend on the temperature. Only the temperature, right? So here the Kc and Kp will change, right? The values will change. Right? The values change. And previously whatever I did, the Kp Kc doesn't change, but here Kp Kc will change. Right? එතකොට ඒක change වෙන්නේ අර මේ exothermic endothermic වලට support කරන විදිහට. right? තේරෙනවද? exothermic endothermic දැන් මේ reaction එක endothermic නම් ඒ කියන්නේ අපි මොකක් හරි මේ heat එක increase කරනවා කියලා. එතකොට endothermic එකට support කරන විදිහට තමයි මේ KPKC change වෙන්නේ. If we reduce the temperature මොකද වෙන්නේ අර මේ exothermic එකට support කරන විදිහට KPKC change වෙනවා. Write down the equilibrium constant for an exothermic reaction. The equilibrium constant for an exothermic reaction. The equilibrium constant for an exothermic reaction decreases as the temperature increases. The equilibrium constant for an exothermic reaction decreases as temperature increases. As the temperature increases. Next on, equilibrium constant for an endothermic reaction. 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 Equilibrium constant for an endothermic reaction increases as the temperature increases. As the temperature increases. right. ඊට පස්සේ තව sentence එකක් දාමු.
So both exothermic and endothermic increases. Endothermic increases more. Okay, is that so?
First sentence. The equilibrium constant for an exothermic reaction decreases as the temperature increases. Equilibrium constant for an exothermic reaction decreases as the temperature increases. Clear? Ne?
So exothermic, when it exothermic, it decreases.
Yeah, exothermic decreases when temperature increases. Clear? Ne? Exothermic දැන් මේක exothermic නම් يعني temperature එක increase කරද්දි ඒක වෙන්නේ නැහනේ. ඒක අඩු මං කිව්වේ. ඒක අර අඩු වෙන්න ඕනේ කියලා. දැන් සිස්ටම් එක ඔපොසිට් නේ වැඩ කරන්නේ. exothermic එක අඩු වෙන්න ඕනේ. exothermic එක අඩු වෙනවා කියලා කියන්නේ ඉතින් endothermic එක වැඩි වෙනවා කියන එක තමයි. හරි? Next one, equilibrium constant for an endothermic reaction increases as the temperature increases. Temperature increase වෙද්දී මේ endothermic එක increase වෙනවා endothermic side එක. ඒක රෝගය අර මේ increase කරන එක විතරයි දීලා තියෙන්නේ. මේ opposite එකත් එහෙම තමයි. හරි? point එකක් දාලා ලියා ගන්න. When we increase the temperature, both reactions
When we decrease them.
no අරක අර එහෙම ඒක ඔළුවේ තියාගන්න අවුලක් නැහැ. ඔගේ ඔය ඕකෙන් දැක්කම තේරෙනවනේ opposite එක කියලා. මේක අර මේ මම අර කිව්ව කතාව. මේක මේ book එකෙත් නැහැ මොකේවත් නැහැ. මේ point out කරගන්නකො. When we increase the temperature, speed of both reactions, the rate of both reactions will increases. Rate of both reactions will increases. Both reactions will increases. Rate of both reactions will increases and reach the equilibrium very quickly. 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 Right. That's why we said from the beginning, equilibrium doesn't explain about the reaction speeds, right? Equilibrium doesn't explain about the reaction speeds. It's only explain about the amounts, right? Amounts. ඒතොර හැදෙන amounts වෙනස් වෙනවා, right? temperature එක change කරද්දී يعني එකක් අඩු වෙලා අනිත් එක වැඩි වෙනවා. හැබැයි speeds මොකද වෙන්නේ? දෙකේම වැඩි. හරි? ඒ වෙන වැඩේ ඉක්මනට වෙනවා. Right? That's the idea. Okay, හරි මේකේ දාගමු. මේ example එක දාගමු. මේක මෙතන
So what's that? 58 kilojoules.
58 kilojoules. يعني මේ side එකේ energy එක අරගෙන මෙහෙට එන්නේ. එන idea එක. මේක නැත්තම් මෙහෙම ලියන්නත් පුළුවන්. ඉතින් මෙහෙට මයිනස් දාලා මේ මොකද්ද මයිනස් මේ මෙහෙට ප්ලස් දාලා ලියන්නත් පුළුවන්. ඉතින් ඔයගොල්ලන්ගේ ප්ලස් මේක ඩෙල්ටා H මේකේ ප්ලස් නේ. එතකොට ඇබ්සෝබ් එන්ඩෝතර්මික් එකනේ. මේක එන්ඩෝතර්මික් කියලා තේරෙනවා නේද? මේක එන්ඩෝතර්මික්. right endothermic reaction. මොකද්ද change එක? increase the temperature. right temperature increase කරාම මොකද වෙන්නේ? System goes to the side that reduce the temperature. Therefore, what will happen? Forward reaction will increases. Forward reaction will increases. Right? Forward reaction increase mention to reduce the temperature. Right. Clear නේ? ඒක ගලපලා ඔළුවේ තියාගන්න. අර රේට් එකත් එක්කත් පටල ගන්න එපා. MCQs වලට ස්ටේට්මන්ට්ස් වලට ඕක පැටලෙනවා. ටෙම්පරේචර් එක අමතක කරන්න එපා මේ. Otherwise you most of the time students think one reaction is increase and I mean let's say you increase when you increase the heat endothermic reaction increases and exothermic reaction decreases, right? It's common නේ. දැන් ඒක අර volume මනම් වල කියන්නේ pressure මේ concentrations වගේ නෙවෙයි මේකෙදි. වෙනස් කතාවක්. හරි? concentration එක එකක් change කරා එකත් එක්ක අනිත් එක වැඩි වෙනවා අනිත් එක අඩු වෙනවා වගේ scene යන වෙන්නේ. මේකෙදි එහෙම නෙමෙයි. දෙකම ස්පීඩ් අප් වෙනවා. හරි? අරකෙදි එකක් ස්පීඩ් වෙනවා. හරි? එකක ස්පීඩ් එක විතරක් වැඩි කරනවා. මේකෙදි එකක නෙවෙයි දෙකේම ස්පීඩ් වැඩි වෙනවා ටෙම්පරේචර් ඉන්ක්‍රීස් කරද්දී. හැබැයි එකක් වැඩිපුර හැදෙන එකක් කියන්නේ එකක් ගොඩක් ස්පීඩ් වෙනවා වගේ එකක්. එහෙම හිතා ගන්න ඕනේ. Right. Then next one, effect of catalyst on equilibrium. Effect of catalyst on equilibrium. What will happen with the catalyst? What is the function of the catalyst? Increase the rates, right? If we add catalyst, it will increase the rates of the reaction, right? Does it involve in the reaction? No, it doesn't involve the reaction. Therefore, when we add catalyst, kind of a thing happen as here, right? The system reach the equilibrium very quickly, right? System can reach the equilibrium very quickly. And does anything change? No, nothing change, right? මොකුත්ම වෙන්නේ නැහැ. සිස්ටම් එකට අක් ගාලා ඉක්විලිබ්‍රියම් එක රීච් කරනවා එච්චරයි. හැදෙලි කරනවා. හැදෙන්න ඕන amount එක ඊට හැදෙන්නේ නැහැ. මේ කැටලිස්ට් තිබ්බා කියලා. හරි? Write down. Catalyst increase the rate. Catalyst increase the rate. Catalyst increase the rate without involving the main reaction. Catalyst increase the rate without involving the main reaction. without involving the main reaction. Without involving the main reaction. Therefore, system reach the equilibrium. Therefore, system reach the equilibrium faster and it does not change the equilibrium. 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 Right? එතකොට දැන් අපි ටෙම්පරේචර් එකේදී කෙලින්ම කියන්නේ අර ඉක්විබියම් කොන්ස්ටන්ට් එකම චේන්ජ් කරනවා කියලා තමයි ඈ. ඒ කියන්නේ අර ගැලපෙන විදිහට ඉක්විබියම් කොන්ස්ටන්ට් එකම චේන්ජ් කරනවා තමයි කියන්නේ වෙන ආයෙ කතාවක් නැහැ. අර මං කිව්ව ටික ඔළුවේ තියාගන්න. ඒකත් ඕන වෙනවා. right. ඔය ටික තමයි තියෙන්නේ. ලේචර් ලිය. ඒ සෑහෙන කැලලක් තිබ්බයි කතාව ගන්න තියෙනවා. හරි next part pH. දැන් ඒක අද පටන් ගන්න බෑ අපි අතන මෙතනින් නවත්තමු. මේ pH වලට යන්න තියෙන්නේ. ඒක තියෙනවා සෑහෙන බලමු අපි ඒක පොළොන්නරම කරගන්න. next week එකේ මේ you don't have classes at the evening and next week මේ විදිහටම Friday තමයි තියෙන්නේ. Friday 8:30 ගමු. මේ කරමු. ඊට පස්සේ මේ අවුලන්නේ දැන් කරලා තියෙන ටික shape අද මේ ටිකෙන් සෑහෙන්න කරන්න පුළුවන් paper එකක් ගත්තාම මේ level paper එකෙත් සෑහෙන්න කරයි පොඩි ප්‍රමාණයක් නැත්තේ. يعني ලකුණු ඇත්තටම දැන් 80කට 80ක් විතර හොයාගෙන තියෙන්නේ දැන්. ඇත්තටම 75 කියන්නේ 75 වලට වඩා يعني ඔක්කොම හරියට දන්න ඔක්කොම හරියට ලිව්වොත් මේ 75 වලට වැඩි ගන්න පුළුවන්. එහෙම ලියන්න බෑනේ. මොකද මේ හරි ඇත්තට ලියන්න පුළුවන්. මේ නැත්te දැන් මොකද්ද ඉලෙක්ට්‍රෝකෙමිස්ට්‍රි මේ last 2 lessons නේ නැත්තේ. මේකෙත් සෑහෙන මේක තව ටිකක් තියෙනවා. මේ half වගේ ඉවරයි ඉතින්. හරි. මේ මෙතන මේ තව එකක් තියෙනවා මේ there is a table මේ ඔයාගාව PDF එක තියෙනවා නේද? PDF එකේ 117 නා 117 බලන්න පොඩ්ඩක් මේකේ අර මේ ලේචර් එළිය වල එන්ඩ් එක. හරිද? 117 මගේ PDF එකේ තියෙනවා. ඔක අර PDF කීපයක් තියෙනවා හොයන්න 117 නා page එකේ තියෙන එක. ඒ කියන්නේ පොතේ තියෙන එක 117 අර read එකේ පෙන්නන page එකක් නෙමෙයි book එකේ තියෙන page එක. There's a table. Right? Summarize table. මේ ඒක ලියන්න හරි print එකක් ගන්න හරි මොකක් හරි short කරලා ඔයාගේම එකක් හදන්න හරි මොකක් හරි කරන්න ඒකට මේ summary එකක් ගන්න හරි lecture එකේ summary එක it's better I mean if you can make it by yourself or just use that right resource book එකේම ගන්න හරි 117 right එහෙනම් good luck for the exam මේ මොකද්ද මේ පාත් සෑහෙන මාක්ස් ගන්න කලින් පාටත් වඩා try කරන්න right මේ ඉන්න කට්ටියට වඩා ඇත්තටම කට්ටිය වැඩක් නැහැ. ඔයාගේ මාක්ස් හොඳට තිබ්බනම් ඇති. මේ කට්ටිය ගන්න වැඩක් නැහැ. මේ papers ටික කරලා යන්න මම මේ paper එකක් දාන්නම් දැන්. මේ එකත් බලන්න past papersම කරලා යන්න පුළුවන් තරම් දැන් අපි කරලා තියෙනවා ආයෙ කරන්න කමක් නැහැ. inorganic case set එක mainly MCQs ටිකක් කරන්න මේ වැඩිපුර අපි ටිකක් MCQs නම් ඇත්තටම කරනවා මදි class එකේ. තිබ්බලින් time මනම් එක තමයි මේ sorry for that ඉතින් මේ උනාට කරන්න මේ පේසිරුව කියන මම ඔක්කොම දාලා තියෙන්නේ දීලානේ තියෙන්නේ ඒ සේරම කරන්න බලලා මේ right ඒ ටික තමයි එහෙනම් let's stop today. Right? Okay, na? Good morning. Good morning. Let's see you next time. Okay,
Thank you,
bye.
sir. God bless you.
Bye. God
Bye.
bless you.